Okay, so you might have solved this in a number of ways. You might have looked at the change between each value in this table and found an average change. You might have just said, hey, they're going down, so it's going to be smaller. I don't know. But one way that you can do this is by putting these values onto a graph. And because these CDs sold and albums downloaded are so drastically different, I'm going to put them onto two graphs. And so I would graph the independent variable here is going to be the year. So we've got 04, 2004, 2005, 2006, and 2007. And we're trying to predict 2010. So I'll put that on there as well. And then, so this is your year. And then on the other axis, we would have, let's start with the albums downloaded. And that goes up to, I'll just go up by 10s. 10, 20, 30, 40, 50. That should give me enough. And now I'm not trying to be super exact here, but 2004 is maybe there. 2005, 13 would be a little bit higher. 2006 would be 27, so maybe like there. 2007 is 42, which is maybe like there. And then if I look, these dots kind of make a line. So if I draw that line, and I draw a line up from 10, I might have to extend this a little bit. 60, 70. That looks about right. So maybe in 2010, they will download 70 million. I went right up to the top of my screen there. Let's scooch that down a little bit. So I would guess that we would have an ordered pair here because the year and the albums downloaded are related. As the years go up, the number of albums goes up, and so we could say 2000. Our graph would probably include something like the point 2010 for the year and 70 million for the number of albums. That's called, when you look at a pattern and you extend it to figure out, make a guess about what might be up there, that's called extrapolation. Now, let me do this other one in red. I do the same thing for CDs sold. I'd make a graph. The years are going to look the same. So 04, 05, 06, 07, 08, 09, and 2010. And I'm going to be kind of squeezing this on here. But my values go from about 500. So I'll make this 500 all the way at the bottom. And they go up to, well, I could just go 500, 600, 700. That'll give me enough room for the data I have. I might need to extend it a little bit to get out here to 2010. But in 2004, we had, oh, actually, no, I won't, because we're going down. 767. So right about there. And then in 2005, we had 705. And in 06, we had 620. And in 07, we had 511. And if we follow that line, well, I should have made this lower, huh? 400, 300. Looks like maybe in 2010 we would have 350 million CDs sold. So my reasoning is that I found a pattern on a graph. And I made the dots, and then I drew a straight line that went close to the dots. The straight line didn't go exactly through the dots, but it was the closest I could get. It was this line, and of course my graphs weren't very accurate either, so this is just an estimate. But this line was the closest that I could get to a line that went through all the dots. So we call it a line of best fit. And there's actually a mathematical way to do this, which is, and I'll show you how to do this on your calculator so you get the best possible line for any points, even if those points aren't exactly in a straight line. And it's called a linear regression. We'll do that later. So the important part to understand here, let me erase some of my things that I wrote over our essential understanding. The important part to understand here is that we took two sets of numerical data. And we actually did that twice. So here's set 1, here's set 2. We took those two sets and we made this, we graphed them as ordered pairs. And by looking at those ordered pairs, we did see that there was a pattern. It's not always the case that you will find a pattern. But in this case, we did see that there was a pattern. And because we saw that there was a pattern, we were able to use a line to estimate or predict values. And we're going to look at better and better ways of doing that in this lesson. There's a couple more vocab words. So what we were doing here was extrapolation, because we were finding points beyond our data set. Our data set ended at 2007, and we were trying to find things out at 2010. But you could also, in some cases, be looking for, like, what is the sales going to be halfway through 2005? I guess that doesn't make too much sense in this situation, but there are situations where finding additional points within your set of data is what you want to do. And if you're finding that, we call that, instead of extra outside, we call it, and I need to write it in a spot where you can see it. We would call finding that point interpolation. And that's just finding data points inside the set, using a line to kind of guess what those might be. Couple more things you need to know. Extrapolation and interpolation aren't super important, but they're connected, so those are kind of bonus vocab words. Linear regression is important. And it's important to know that when you do this, when you graph as ordered pairs two sets of numerical data, the thing that you're creating is called a scatter plot. So both of these things are scatter plots, and we're going to look at a lot of scatter plots today, and we're going to learn how to do some cool tricks with your calculator with scatter plots. Couple things that, so like the first thing that you're going to be asked to do is put data on a scatter plot. We're not going to use a calculator at first. We're just going to do it by hand. And you don't have to be super accurate. You just have to be accurate enough to tell, is the data going kind of an upward line or a downward line, or is the data just all over everywhere? And there's no real line that we could draw. If the data is going up, we call this a positive correlation. If the data is going down and it has a negative slope, we call it a negative correlation. And if the data is all over the place, we say there is no correlation. All right, so at first, all we're going to be doing is graphing the things roughly enough to say positive correlation, negative correlation, or no correlation. So it'll be questions like this are what you're going to do in just a moment. Making a scatter plot and describing its correlation. So the table shows an altitude of an airplane and the temperature outside the plane. Let's see what kind of correlation there might be. So I'm going to make a scatter plot. And again, this is rough. I don't need any of these points to be exact. I just need to know in general what's going on. So I've got altitude and temperature. I think altitude would be the independent variable. So this scale is going to go from 0 up to 5,000. I'll just go up by thousands. 1,000, 2,000, 3,000. I probably should just wrote K instead of trying to squeeze all these zeros in here. And then my temperature, it gets almost all the way down to 0 at 5,000 feet. So I'll start at 0, and it gets as high as 59. So I'll just go to 60, 10, 20, 30, 40, 50. This is not going to be perfect. And let's label these altitude, and this one is temp. Okay, so at an altitude of 0, our temperature is 60. I'm going to make the points a different color so they're easy to see, or is pretty close to 60. At 500, it's actually a little bit warmer. At 1,000, it's even warmer than that. At 1,500, now we're down to 55. 2,041. 3,000 is about 30. Oh, I missed 2,500, which was also about 30. 3,500 is about 18, so pretty close to 20. 4,000, 26. 4,500, 12, 5,000, pretty close to 0. So if we connected those dots, they're not going in a straight line. They're going kind of all over the place, you know? Sometimes they're going up, sometimes they're going down, sometimes, you know. So that line doesn't help us too much. But if we were to just roughly draw a line that goes as close as we can, if we were trying to estimate our line of best fit, it would look something like that. And that line's going down. So we can say that this has a negative correlation. So on the next slide, there's a couple problems like that for you to try. Give them a shot. Make sure you state whether the correlation is positive or negative. And then we'll look at how to do way better at estimating that line of best fit using linear regression tools on your calculator.